Hey everybody, this is Mr. Backstrom, and today I want to look at an example from homework 6.6, and it says find the amplitude, period, and phase shift of the function. Graph the function and be sure to label key points and show at least 2 periods. And then at the end of this one, I want to show how to use the graphing tool in my math lab. So let's go ahead and work on solving this. A lot of this is going to be very similar to some of the previous sections that we did. So let's do the easy parts first. So for the amplitude, well, actually, let's go ahead and put this in our form because that part's actually going to be a little bit tricky for this one. And we're going to use this book's notation, which is going to be a little bit different than some of the other notation that I've seen in other books. But if we have it in this form here, and it's going to be y is equal to a times the sine of, they're using the omega symbol, x times x minus, they're using a phi, that's another Greek symbol. It kind of looks like a theta, except the line is vertical there, like this. If they're using this, then what we can do is we can also write this like this. A is equal to a times the sine, and we're basically going to be factoring this omega out of these terms here. So I think I just wrote an s instead of an n. Sine, and we're going to go ahead and write it like this. So pull the omega out of these two terms, so it's going to look like x, pull the x out of there, minus, and then pull the omega out of here, so you're going to divide that term by omega as well. And you can see this in the book on page 431 if you want to take a look at this. And this is important because once we put it into this second form here, this part here will actually describe our phase shift once it's in this factored form here. And this will also, either way, either of these forms will help us find our period and our amplitude, but this factored form here will actually give us the phase shift that we're going to need to use to find that part of it. All right, so for this problem here, notice that it's in the first form, so we're going to want to put that into the second form there. So let's go ahead and do that right now. So we're going to equal -5 sine, and we're going to pull that 4 out. So we're going to have x plus, and pi over 2 divided by 4. That's the same thing as multiplied by 1 over 4. So pi over 2 times 1/4 is pi over 8. Pi over 8. All right. So now we have it in the second form here. So that means that our phase shift is going to be the opposite sign, because remember we have it in our formula here, we have a minus sign, so it's going to be the opposite sign of whatever's here. So our phase shift is going to be a negative, or a minus pi over 8. All right, so let's go over here. So our amplitude, and I'm going to shorthand this, our amplitude is equal to the absolute value of a, which is -5. So the absolute value of -5, so that's just going to be equal to 5. Our period, that's going to be just our 2 pi divided by our omega here, which is 4. So 2 pi over 4. So this is going to reduce to pi over 2. And our phase shift, and we found that by factoring out the omega from the two terms here. So that's just going to be a minus, because we have a minus in our formula, minus pi over 8. So that's going to be a negative pi over 8. So before we do this next part, let's see how we actually graph that in our calculator here. Actually, not our calculator. In my math lab. So I come over here. I am using the Sine tool. So I'm going to plug that in there. Just put it anywhere. It'll put a sine in. And let me make it so we can all see this. Oh, sine. All right. Okay. All right. So our amplitude was 5. And it was a -5. So we're going. Oh, let me clear everything out of here. Okay. So sine. Put it in there. We have an amplitude of 5, and it was a -5, so we're going to reflect it over the x-axis. That's what the negative out front means. We have a period of pi over 2. So I'm going to show you how to put a pi in here because we don't see a pi button. So you can just type in pi, and it'll put the pi in there for you. I know some of you are having trouble with that, and then you can just do the backslash, and it'll automatically do the fraction over 2. So that will be our period, and remember that's your omega divided, or 2 pi over omega. And then for our phase shift, we said that was negative pi divided by, so that's the backslash over 8. And I believe that's everything here. So let's go ahead and save that. Where is, I might have to go to full screen there, and oh, save this right. There we go. And there we go. And that is how we graph that on my math lab. All right, so let's actually do a little bit of this by hand as well, just to see how we would go about doing that. So if I were to, oh my lord, I need to use my ruler for this, don't I? So let's pull out the ruler. So let's see how this would look. So let's start with a normal sine curve and see what would happen to it. Alright, so let's say we had normal sine curve, and so I had 0 pi over 2 pi 3 pi over 2 and 2 pi, and I went from 1 to -1. I'll change the color here. Our normal sine curve is going to look like this. So it starts at 0, 0, it goes up to there, goes back to 0, 0 at pi, gets down to here, and it makes a full cycle at 2 pi, and then it keeps on going. And negative pi over 2. Alright, something like this. I know it asks us to do full 2 periods, but we'll just do like 1.5 there at this point. Alright, so how do we do this? Well, we know that we need to go, and this is not the scale, but we need to go up to 5 and down here to -5, because this is what happened to our amplitude. We know that the minus out front flipped us over the x-axis, reflected us over the x-axis, and we also know that this 4 here, along with this pi over 8, changed our period and our phase shift. So our period got shrunk to pi over 2. So that means our entire cycle ends here, right here, and it also means that our sine curve got shifted negative pi over 8, so pi over 8 to the left. Now to find our key points here, we can start at negative pi over 8 and we can move, remember our period is pi over 2, so if we divide pi over 2 by 4, that'll give us our increments there. So let's do that right now. Pi over 2 divided by 4 is the same thing as multiplying pi over 2 by 1/4. So that would be pi over 8. So if I started at negative pi over 8, which would be like right here. So negative pi over 8. And remember, so each increment of pi over 8. So 1 would bring me back to 0. And then I've got pi over 8 here. I've got pi over 4. I've got that would be pi over 8. That's pi over 4, right? So that's 2 pi over 8. 3 pi over 8. 3 pi over 8. And this would be 4 pi over 8, which is pi over 2. So it would make its complete cycle to here. So we're looking at a curve that starts here. It's going to go down. So it's going to go all the way down here because it's reflected. Comes all the way back up here. Goes all the way up here. All the way down there. And then it finishes all the way down there. And then it'll keep coming back like this. Let's see if we can see this in our calculator. Make sure we got that right here. So put this into radians. Remember, usually when we're graphing these sine functions, cosine functions, any trig functions, we like to do radians. Take that out, and we're going to do negative 5 sine. I'll put it in this first way here. So sine 4x plus pi over 2. Second pi over 2. That looks right. And to get us, well, let's see how this window looks. Just a normal standard one. So let's do a standard to start with, because this looks like it might be right here. And sure enough, it kind of starts just to the left of our origin there, and it goes down all the way to negative 5, goes up. So it should end right about, yep. That looks right about right. All right. Well, if y'all have any questions, make sure to let me know. I hope this helped with the graphing tool and getting those key points. If you have any questions, yeah, let me know. All right. Thanks, everybody. Have a good week. Bye-bye.